Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video, sample problem video on cables under structural analysis. And there are two parts. We treat the cable as we treat the cable approximately as parabolic, and the second one as catenary. So it should be the exact treatment is catenary. For a certain value of P, the span-sag ratio for the cable shown is L over D equals 12. So find the span-sag ratio will be if the load P is doubled. So treat the cable approximately as parabolic and treat the cable exactly as catenary. So because the span to sag ratio is 12, and by experience, as long as the span to sag ratio is at least 10, in this case it's more than 10, then we can treat approximately the cable as parabolic. But the exact treatment of this is catenary. So the supports are symmetrical. This P here would serve as the tension, and the horizontal component of tension is equal to WL square over 8D. Remember, we derived this. Then the vertical component, because of symmetry, is in general the uniform weight of cable times x, where x is L over 2 in this case. So tension, which is square root of horizontal component of tension capital H square plus the vertical component of tension Wx quantity square, where x is L over 2 in this case. So for parabolic cable, the origin is at the lowest point here. So this is the y-axis. So for part A, tension equals P equals square root of horizontal component of tension square plus vertical component of tension quantity square in general, where x is L over 2 or 0.5 L and h is WL square over 8 times the sag. So WL square over 8 times D, that's h. Substitute into the formula, P equals square root of WL square over 8D quantity square plus W times L over 2 quantity square. So we can factor out W square. It is common, and square root of W square is W. In fact, we can also, the first term here is W square L to the fourth. And the second term, we have W square L square. We can factor out W square L square. The square root is WL out. And let's simplify. So let's have W first. Let's break L square here into L times L, then over 8D plus the second part after we put W outside the radical is L square over 4. And take note that L square is common again. We can factor out square root of L square, which is L. And take note that here L over D is to be replaced by 12. So P equals W 12L over 8 quantity square plus L square over 4. So 12 over 8 is 3 halves square, then 1/4. Then we factor out square root of L square, which is L. And that would be WL square root of 10 over 2. So that's the value of P. Then for the second part, it is 2P, and we will call the sag this time as D prime. We expect that D prime will decrease because P is doubled. So 2P is 2 times WL square root of 10 over 2, and that is WL square root of 10. Then we equate this to WL square over 8D prime. We call the new sag as D prime when the tension is 2P, and this vertical component is still the same. So square root of WL square over 8D prime quantity square plus WL over 2 quantity square. So we can cancel W, we can cancel L also. So square root of 10, what remains here is L over D prime, and we will call that R, the ratio. So WL square root of quantity L over 8D prime plus 1 half quantity square, and we replace L over D prime by R here. We can cancel WL. So square root of 10 equals square root of R over 8 quantity square plus 1/4. Squaring both sides, so 10 equals R square over 64 plus 1/4. Then R square can now be computed. 10 minus 1/4, then times 64. So 624 equals R square. Finally, R is square root of 624, and approximately that is 24.98. So therefore, the span to sag ratio when P is doubled is approximately 24.98. So you can make it 25 if you want. Then for the second part, treating it as catenary. This is the correct treatment of this cable because the weight of the cable is uniform along the curve, along the arc, which is catenary. So we locate the origin, which is below the lowest point on the cable and at distance C from the lowest point. So this is now the new origin. Call this C, and that is D. And tension equals W times Y. So Y is just C plus D as shown. So tension equals P equals WY, and Y is just C plus D. We can cancel out W. So Y equals C plus D. And the equation of the catenary is C cosine hyperbolic of X over C. So Y equals C plus D, and L over D is 12, therefore D over L, or D is L over 12. So substitute D equals L over 12, then we find C in terms of L, and we substitute it into the equation of the catenary, which is Y equals C cosine hyperbolic of X over C, where X is 0.5 L by symmetry in this problem. So C plus L over 12 equals C cosine hyperbolic of 0.5 L over C. So using your calculator to evaluate C, your calculator is capable of evaluating C. You just imagine that L is 1 when you compute for the value of C. Treat L equals 1, but C is in terms of L. So solving for C, C is 1.5137 of L. So therefore, Y is 1.5137 L, which is C plus L over 12, and that is equal to, in decimal, 1.59703 of L. Then the tension, which is 2P, is 2 times WY. So Y prime is C prime plus D prime, and it is C prime cosine hyperbolic of 0.5 L over C prime. And the new Y prime is equal to, so from tension, which is equal to 2P, equals W times Y prime. So tension prime equals WY prime, 2 times P. We can cancel W, so therefore Y prime is 2Y. So C prime plus D prime, that's Y prime, equals 2Y from this equation after we cancel out W. So we have Y prime, which is C prime plus D prime. And on the right side, we have 2Y. And Y is 1.59703 L. So C prime plus D prime is 2 times 1.5903 of L. So that means C prime plus D prime is equal to 3.19406 of L. Then we substitute it into, because this is Y prime, into the equation of catenary, into this equation here. So 3.19406 L equals C prime cosine hyperbolic of 0.5 L over C prime. So from there, we can estimate the value of C prime in terms of L. So just like what we did in here, we imagine that L is 1. So supposedly C prime is in terms of L. So using the calculator, C prime is equal to 3.15435 of L. Then we substitute it here. 3.19406 L is C prime, which is equal to this plus D prime, so that we can solve for D prime. So 3.19406 L equals 3.15435 L plus D prime. So D prime, therefore, in terms of L is 0.03971 of L. So that means L over D prime is 1 over 0.03971, and that is approximately equal to 25.18. So that's the ratio. It's approximately 25.18. So you see that the ratio, if treated as exact cable, which is catenary, is still close to that of the parabolic approximation. So that's it for this problem, and I hope that you learned something from this solution. I hope that you can master cables, and not only cables but also topics on structural analysis.